Okay, I am doing this video on Laplace transform. What is Laplace transform and its properties, and Laplace transform of different functions. This is helpful in solving the differential equations using Laplace transform, especially in transient analysis. You have already studied, but some of the students not confident. So keeping those students in mind, I am making this video. So all of you listen. Laplace transform. I am not discussing much on theoretical concepts, advantages and disadvantages and so on. This you study anyway in signals and system. So what is Laplace transform formula is? So for example, f of t, Laplace transform of f of t is indicated with f of s. So integral 0 to t f of t e power minus st d. So this is the formula. Now, what are the different properties? So, for example, time shifting property. Time shifting. F of t minus a. F of t shifted by a. Its transform is f of s e power minus as. So time shifting here minus, here also minus. Time is shifted, but frequency domain multiplied with exponential. So now what is the use of this? For example, ut Laplace is 1 by s. What is ut minus a transform? Same 1 by s multiplied with e power minus as. So that is the advantage of this property. Second one, frequency shifting property. If f of t multiplied with e power at, frequency shifted f of s minus a. So when time function is multiplied with exponential, frequency domain shifting. So that's why it is called as a frequency shifting. But here e power at, here s minus a. So that is important. So for example, e power minus at transform is 1 by s plus a. Then sin bt transform. b by s square plus b square. Then e power minus at sin bt transform. So first you have to write f of s minus a. So that means what? B by s plus a whole square plus b square. So this function is multiplied with exponential. This transform, wherever s is there, replaced with s plus a. If this is e power plus at, then s minus a. So that's the advantage of frequency shifting property. It can be any functions we can write, like u of t e power 8. So what is ut transform? 1 by s. So ut is 1 by s. So that is multiplied with e power 8. So s minus 8. Like this. Because e power minus 8, then you'll get s plus c. That is frequency shifting property. Third one is scaling property. F of at transform 1 by a f of s by a. This is called as scaling property. Scaling property. It is like f of t transform is f of s. What is f of 2t transform? 1 by 2 f of s by 2. Okay. For example, sin bt transform b by s square plus b square. What is sin 2bt transform? Is 1 by 2 b by s by 2 square plus b square. So like that, here t is multiplied with 2 now. Like that you can find. This is scaling problem. Time differentiation. df by dt transform s into f of s minus f of 0 minus. If it is d square f by dt square, s square f of s minus s into f of 0 minus f prime 0 minus. So here time domain differentiation, time differentiation. Time differentiation problem. So these things we are using very much in transient analysis. When you are applying Laplace transform to differential equation, we use this. Time differentiation. Frequency differentiation. P f of t transform. minus d of s by ds. So this differentiation frequency domain. So we call it as frequency differentiation property. Time differentiation frequency. Then time integration. Integral minus infinite to t f of td is f of s by s plus f of 0 minus by s. If it is 0 to t, you get only the first term. If it is minus infinite to t, you get second term also. For time integration. Time integration. Frequency integration also there. F of t by t. Integral is to infinite f of s ds. Frequency integration. Frequency integration. Here time integration. So if you observe these two, here f of t multiplied with t, frequency differentiation with negative sign. Here f of t divided with t, frequency domain integrated. Then convolution or before apply. So what is the use of fourth and sixth? Fourth and sixth. When I am writing differential equation, example d square I by dt square and 2I of t plus integral and minus infinite to t I of t dt equal to u of t. So to apply Laplace transform, you have to take s square I of s minus s into I0 minus I prime 0 minus plus 2 I of s plus 10 I of s by s plus I0 minus by s is equal to Laplace of ut is 1 by s. So this is an application. So transient analysis, we use the Laplace very much. Next, eighth one. Time convolution. F1t star F2t. Laplace transform is F1s F2s. This is time convolution. Time convolution. What is this formula expansion? F1 tau F2 t minus tau d tau. So what is the meaning of convolution? You will understand in signal scientist. Frequency convolution also there. F1t F2t. 1 by 2 pi j F1 of s star F2 of s. So frequency convolution, here time convolution. This is useful in time convolution is useful in inverse Laplace transform. Okay, using this, all properties are useful in finding transform and also inverse transform. Then initial value theorem. F of 0 plus a value of function at t equal to 0 plus is limit s tends to infinite s into f of s. Similarly, final value theorem. F of infinite final value limit s tends to 0 s into f of s. S tends to 0, s tends to infinite. At 0, infinite. At infinite, the final value here. Okay, so all these are important properties. Then some standard functions, how to find. For example, Laplace of impulse function is 1. U of t is 1 by s. Only t. T u of t 1 by s square. T to the power of n u of t. Factorial n by s power n plus 1. Then e power minus at 1 by s plus a. Sin bt b by s square plus b square. Cos bt here s by s square plus b square. If it is a hyperbolic function, hyperbolic bt is b by s square minus b square. Cos hyperbolic bt s by s square minus b square. So these are the standard functions. Frequently we use it. Laplace of k constant is k by s. So these are the directly, but sometimes you have to, for example, t u of t minus a, or otherwise let us take simple one, t minus a ut minus a transform. What is that t Laplace? 1 by s square, na? 1 by s square. So time domain shifting, frequency domain multiplying with exponential. S square e power minus as. So it's a time shifting frequency domain. T transform is 1 by s square. So t minus a ut minus a transform is. Sometimes they confuse like this. T ut minus a. Now don't apply property directly. This is equal to t minus a plus a. Then u t minus a is equal to what? T minus a u t minus a plus a into u t minus. So what is the first one? 1 by s square e power minus as. Second one a ut transform is 1 by s, and ut is shifted by a, na? E power here. Yes. E power minus as. So like that you should be careful. E power minus at sin b by s plus a whole square plus b square, using frequency shifting. Using frequency shifting. So all standard functions to Laplace transform. Next, inverse Laplace transform. To find inverse. Inverse Laplace transform. For example, 10 by s into s plus 1 s plus 2. So this is f of s given. You have to find f of t. So how to expand this? 10 by a by s plus b by s plus 1 c by s plus 2. How to find a? So take LCM, comparing the coefficients you can do. That's the old outdated method. Directly how to find a? So SS cancel, 10 by s plus 1 into s plus 2 at s equal to 0. So you will get 5. Similarly, b 10 by s into s plus 2, simplify at s equal to minus. So you will get minus. Then c 10 by s into s plus 1 is equal to minus. So you will get minus minus plus, so 5. So using this, f of s is what? A by s. A by s. So a is 5 now. 5 by s minus 10 by s plus 1 plus 5 by s plus. So what is f of t? 5 u of t minus 10 e power minus p plus 5 e power minus 2t. So like this we can do. Second example, if I have 10 by s square s plus 1. Because of this s square, we write a by s, b by s square, c by s plus 1. If it is s cube is there, a by s plus b by s square plus c by s cube, like that you have to write. If s plus 2 also there, then d by s plus 2 will come. Now we can find b, s square will go 10 by s plus 1 at s equal to 0. You will get 10. C also you can find easily. 10 by s square at s equal to minus 1. So at s equal to minus 1 square plus again. But a you can't find like that. So how to find a? 10 is equal to, or take LCM, s square s plus 1 is equal to s square s plus 1. So we get as plus b, so here s plus 1 plus b s plus 1 plus c s square. So this denominator cancel. Compare the s square powers. What is s square power? There is no s square term, 0. A s square. So what is s square coefficient? A. Here c. So a plus c equal to 0. Already c equal to 10. So from this a equal to what? Minus. Like that, by saving time, you can do it. So BC is straightforward, but A, like this, fastly you can find. So finally, what is A value? Minus 10 by S plus B 10 by S square plus C. C is 10. C by S plus 1. So what is f of t now? Minus 10 u of t plus 10t u of t. Here C value is 10. So 10 e power minus t u of t. So this is a third example. Sum 10 by s into s square plus 2s plus 3. So here you have to expand like a by s. Now bs plus c by s square plus 2s plus. So as usual, 10 is equal to a into s square plus 2s plus 3 bs plus c into s. So compare the first to put s equal to 0. So when you put s equal to 0, 10 equal to this cancel 3a. So here s is 0. So what is a value? 10 by 3. Now compare the coefficients. S square, if I compare, left side 0, a plus b s square. Na? So what is b from this? Minus 10 by. Then s powers compare, left side 0, here 2a, here s power is c. So c is equal to minus 2a. Minus 2 into 10 by 3. So minus 20 by. So like this, substitute, then find the inverse Laplace transform. Okay. So these are the different methods. So practice Laplace transform, inverse Laplace transform, properties, and so on. All these are important, helpful in second unit of transient analysis. So now I stop here.